Our next spokesman has been helping users of Apache Cassandra at DataStax since 2012. He started as a Cassandra contributor in 2010 and has worked with users and enterprises across North America, Europe, and Asia. Along the way, he has contributed to multiple projects such as Apache Hadoop and Spark. Currently residing in Sydney in Australia, he has been an active contributor to the Apache Tinker Top community. In his workshop, we will get to explore how to deploy and manage a data tier based on Apache Cassandra cluster in Kubernetes using K8ssandra. Ladies and gentlemen, please help me welcome Mr. Jeremy Hanna.
Hi, everyone. My name is Jeremy Hanna. I work at DataStax, a commercial vendor behind the Apache Cassandra project. And I'm here to talk to you about how Cassandra can run in a cloud-native fashion from a developer perspective, from an operations perspective, and all of that. I've been at DataStax for about 9 years. I've been in the Cassandra community for about 11 years, working with other projects that are kind of in that whole ecosystem. And I have some interesting information as we've tried to pivot to make Cassandra a first-class citizen in Kubernetes and in a cloud-native world. So thank you for joining today. Today, what we're going to do is, under normal circumstances, we might have a hands-on portion of this, but for the purposes of this, we want to cover these topics so that you can follow along, as well as go to the K8ssandra.io website and the Discord room if you have any questions in addition to after this conference. But during this conference, I'm happy to answer any questions as well. I'd like to start with some basic understanding of what Cassandra is, and then talk about what K8ssandra is. You know, people always like to have a play on words when it comes to project names. K8ssandra is a combination of Kubernetes and Cassandra, and then go through the various things that are needed for running Cassandra well in a Kubernetes environment, and how K8ssandra can help with that, from operator Helm charts and configuration to best practices with the database, and doing everything that you would need to do for like the day 2 operations for the database, such as repairs and backup and restore and scaling and all of that kind of thing. So that's what we're going to be covering today. So just starting off with the basics of Cassandra. Cassandra was made for a world that needs to scale linearly. So when we say that, it's when you have 8 nodes, you have a certain throughput, and then it doesn't really matter because the profile of the hardware changes over time. But just know that if you have the same hardware with 8 nodes, if you have 16 nodes, you should theoretically and in practice have 2 times the capacity. So you can retain your SLAs for your read and write latency, and increase your throughput by 2x between 8 and 16 nodes. And we have clusters that go up to 1,000 or more servers in the cluster. So it partitions and replicates the data for you, and then it scales the database for you. And we'll talk about how it does that a little bit before we get into the talk about K8ssandra and the Kubernetes integration with Cassandra. So how does this work? We have in this table over here a set of data, and what we want to do is to say we have a use case where we need to get the cities for these countries and associated metadata like population. And so what we're saying is the partition key to get to this data is in this column here. And so what we'll do with Cassandra under the covers, we'll take the partition key and hash it with a hash algorithm, which is murmur3, which will assign, hash this value into a numeric value, and then that will be a consistent hash for how it's distributed to the ring, how it's partitioned. You don't have to do this. This is done for you by Cassandra, but this is just to give you an idea of what's going on underneath. So in this case, we've distributed these across the cluster in an even way based on the partition key. And then besides the partitioning around the ring, say we have, so murmur3 produces a value between -2 to the 63 to +2 to the 63. So it's a lot of numbers. For the purposes of this diagram, we're just doing it from 0 to 100 because it's a little easier to grasp. So you can store pretty much any amount of data that you want to within the cluster, but this just shows a representation of how data is replicated within the cluster. So not only is it sharded, or there's the consistent hashing mechanism to put the data in the cluster in a predictable way, so you always know that data that hashes to the value of 15 will be stored on this server because this covers the range from 0 to 17. But it also replicates. And so this is the first replica range, that's the second replica range, and that's the third replica range. Typically within a data center, you have 3 replicas. So if I have a piece of data that hashes to 59, I send it to those 3 servers because it's this server, or this server. So it's this server, and this server, because it just replicates in order of the ring, right? So it goes to the destinations across the cluster. However, say one of those servers is down for maintenance, for an upgrade, for an operating system patch, or a drive is down, or you're just doing some configuration changes to the database and you're doing a rolling restart of the cluster. Whatever that reason is, that database server is down temporarily. And you can talk to, and I should take a step back, application servers can talk to any node in the ring because any node in the ring has awareness of where all of the data is stored because it's stored in a consistent hash type of manner. And so if some client talks to this server and says, I want to store this data, it can say, I can directly talk to the 3 nodes where that data needs to reside. And if this one is down temporarily, it can store what's called a hint, which is basically serializing the mutation at the coordinator over here and waiting for that server to come back online, and it will replay the hint to that server. And in that way, you never have to go offline. So in a Kubernetes world, sometimes you'll have a rolling restart because of configuration changes, or you want to add a node to the cluster, or you want to do any one of a number of things. And any of those events doesn't have to require downtime because Cassandra, since its beginning in 2008, has always had this mechanism of you have replication, and if one of the servers goes down, there's a number of ways for it to get back to consistency among the data replicas. The other facet to this is that you have fault zones. So you might have 3 racks if you're in an on-prem deployment, or if you're in a cloud in a cloud region, you might have availability zones. So you'll see that every 3rd node is in a different fault zone. And so Cassandra uses that information. If you give it that information, like the rack information or the region availability zone information, it will make sure that it will replicate across the different regions. So for example, Netflix, it replicates within AWS. It replicates across all 3 availability zones in that region. So if there is a problem with one of the availability zones in that region, then you still have 2 other availability zones that have that one piece of data. So they never have experienced a second of downtime in all the time they've been using Cassandra since I think about 2012, 2013. Around that time is when they started. They now have about tens of thousands of servers, and that's managed by only a handful of individuals. And then we generalize this concept for Cassandra to say that because it's a masterless architecture. There's no leader, there's no special server in here. It just has a consistent hashing within each data center and replication within each data center. You don't have to have any sort of leader or follower and that sort of thing. It's masterless. And so we generalize that concept to say, if we want to go across different geographic regions, or if we want to say, I'm starting on-prem. So a lot of companies are starting on-prem and saying, well, I want to grow, but I don't want to have my data center space grow. And so I'll have an additional set of replicas in the cloud. And then say over time, there's a feature that Google Cloud has, maybe the machine learning that they are kind of more advanced in, or maybe they have price improvements that are, you get a lot of credits or something like that. Then maybe you want to replicate over to Google Cloud and decommission your AWS deployment, or vice versa. So Cassandra is able to cross these regions and cross these clouds really easily. As long as your networking is set up such that you can replicate across, it will do that for you. And all of this is done as an implementation detail for developers, but for the DevOps community, just know that this was built from the ground up to be able to do this. There's different deployments out there that I've talked about. Apple, I think they're up to about 250,000 servers running Cassandra, hundreds of petabytes stored, several million operations per second. And Netflix, it has tens of thousands of Apache Cassandra nodes, hundreds of clusters. And so you can take confidence in the fact that people are using it in these very large scale ways. And like Netflix, I know they have about 8 people maybe managing those tens of thousands of nodes. And so that's a testament to what we aspire to as SREs and DevOps types of people, to say that this is a database that can be scaled with automation and with best practices and the practices that we're familiar with and that we're talking about at this conference, that this can be very doable for us. But let's say that we want to just take those same concepts and deploy them into your normal Kubernetes cluster or control plane and services. You have 90 minutes, ready, set, go. We're not going to ask you to do that here, or even if we had more time. That's not really what we're trying to do. I mean, there's a lot of different stuff to do. You have firewalls, you have all the different services to install, the agents, the backups, repairs, and user agents, storage, and all of that. There's a lot to do. And so we come to the point where we realize even Kubernetes alone is not enough to make our lives easier unless we have something to help us. And so that's kind of the motivation for the project called K8ssandra. K8ssandra is a fully open source project. It's the database of Cassandra and all of the administrative tools to make it, cloud native, for the definition that you might think is cloud native. And we can go over what that whole stack means here. K8ssandra has like a lot of different documentation, but it starts with the full project, which includes an operator and includes Helm charts and includes configuration. So if you're familiar with Cassandra and you're familiar with the storage in stateful sets in Kubernetes, some of this should look familiar for you. And so what we're doing here is we're configuring a Cassandra cluster and giving it some basic information. So our data center name and our size and the resources that we have available for it. And we have something called Stargate that we'll talk about in just a little bit. And we have our Prometheus stack. And so what we have is a full stack that is Kubernetes friendly. So for instance, Prometheus and Grafana. And we have other tools that live within our Kubernetes control plane to help us. for the day 1 and the day 2 operations. So there's something called Cass operator, and that's a component of K8ssandra. And that's what does all of the heavy lifting when it comes to, okay, well, I've changed my declarative environment and I need to adapt to those changes. And instead of just saying, I'm going to blindly do those operations, Cass operator is kind of like the filter that it goes through to say, okay, I know what you're trying to do. Are you trying to change configuration within your cluster? But I know about Cassandra, so let me deal with that part. And I will change the configuration, and then I'll do a rolling restart through the cluster so that my applications still have a database that they're talking to while you want to change the configuration. So Cass operator is really nice for that. And it does a bunch of other things as well. Stargate, that I mentioned just a minute ago, is a data gateway that provides REST, GraphQL, and document APIs, which is kind of like a schemaless document database through with JSON on top of Cassandra. So when I spoke to some of the people that I know at Netflix, those 8 people or small number of people that manage Cassandra, they don't give them direct full access to the database, right? There's not only the ability to have control user grant permissions and things like that within the database, but there's best practices that you follow, database paging and scanning and filtering and all that kind of stuff. And so the developers at Netflix, what they say is, okay, well, we'll give you an API that you can use to get to your database, and we'll handle all of the DBA sort of things ourselves. And so that thinking is what prompted, that sort of thinking was what prompted Stargate to say, okay, well, we want to bring REST and GraphQL and kind of document API developers to be able to use this very scalable database in a cloud native world, but they don't want to have to learn all of the details about Cassandra. So you can speak the Cassandra query language and use the Cassandra drivers against Stargate directly, or you can also you're also exposing a REST, a GraphQL, and a document API endpoints to adding that to Cassandra. This is a separate set of lightweight nodes that are running Stargate, and they're the gateway between your applications and Cassandra. And it will serialize down from REST down to CQL, and from CQL to Cassandra, and then it goes back through, and then the native result format gets deserialized or reserialized as JSON or whatever you're expecting from the client's perspective. Like with GraphQL, it'll reserialize that data and pull it back up through to back to the application. So it makes it so that your developers don't have to worry about what's under the covers. That's kind of the take home. And it has traffic and others, like you can configure that. There's different in the project, there's different tutorials and best practices on how to configure different types of ingress for external access. And there's other utilities for keeping the database in sync. As soon as you have 3 replicas per data center, so that might be 6 or 9 replicas if you have 2 or 3 data centers. We have hinted handoff, which is what I mentioned before, but there's also a background process that just goes and not cleans things up. It goes through and makes sure that all of the data is in sync, right? As soon as you have a distributed system with lots of replicas, and that's really helpful that the database does that for you, so that when I'm in Mumbai or I'm in Western Europe, I have data that's close to me. And then if one of those data centers goes down for whatever reason, you have the other data center. So it's nice to have that replication, and it's necessary for fault tolerance and resilience and preserving latency to my local markets. But that background process is really helpful to keep that all in sync. And so Reaper is a tool that's built into K8ssandra that keeps data in sync for you. And of course, if you have a data system, you probably want to do snapshot backup and restore. And that's what Medusa does. It goes out and it does a consistent backup and then sends that back to the object storage. So if you're using a cloud Kubernetes engine, that might be Google Storage or S3 or something like that. But in a Kubernetes, like in a on-prem or your own Kubernetes environment, that would probably be something like MinIO, which is a kind of like a object storage facility in there. And so that those two utilities handle those operations for you. And then, of course, with metrics aggregation visualization, there's integration. So Cassandra's metrics, we have a metrics collector for Apache Cassandra in there that basically sends the metrics to an on-disk format, and then that goes out to Prometheus. And so that it's a very scalable that way. It's not querying the database directly. The database stores those metrics locally, and then it gets sent out to Prometheus, scraped by Prometheus, and then that goes to Grafana for visualization. And then all of this is packaged and delivered via Helm charts. So that's kind of the full picture of how K8ssandra works. And like I said, a lot of this is just, for your information. All these things are available to you and they're configurable, so you don't have to use certain features of this, but it's kind of a complete package to say, if you're wanting to run Cassandra in Kubernetes with kind of stateful sets, and that your company is trying to migrate to that whole philosophy of DevOps going towards a cloud native world, and there's a number of benefits to that. This is already well on the path for you, so you can focus on getting, bringing this in as part of your overall architecture. And so this is how it's set up. And so here's your applications. This could live in, a serverless environment, some sort of Lambda type of system. And then it comes in through your ingress. And then the microservices can talk to our data gateway. And this is a few nodes that act as a data gateway. It's stateless and horizontally scalable, elastic, and so you can scale that independently if you want to. And this talks to your Cassandra database, and then there's a number of things on the side. So the Prometheus will collect all of the metrics information, and that's exposed through Grafana, and then Reaper has a sidecar that talks to Cassandra to make sure that everything stays in sync. Medusa stays in sync with the sidecar also to make sure that the backup and restore is going according to its scheduled processes. You want to make sure that periodically you take a backup in case there's some bugs happen, and so you don't want to lose your business. And so these are the tools that are available to your operators, that your DevOps team that is managing all of this. And this is your Kubernetes cluster, and they manage it through Helm. And then obviously the backup and restore has to go someplace. And so this is whatever object storage you have as part of your environment. And this is the storage at the back end. And this is one of the trickiest parts, because originally Kubernetes was great for, you had semi-stateless services, because you have to have some in-memory state and that sort of thing. But when it comes to having an actual database in Kubernetes, that's a completely different matter. And so it took a while. They were originally called pet sets, I believe, and they became stateful sets. And stateful applications that are, fully, database style stateful came into Kubernetes, and it's been a few years. I think it went GA in terms of storage for this sort of thing in 2019, I think, 2018. No, I think it's 2018, the end of 2018. But you have the concept of a persistent volume and a persistent volume claim and a storage class. And that gets into whatever Kubernetes engine you're running. You can have a local persistent volume. You could have, EBS or, the Google volumes. And then you have a stateful set that creates and manages that. So the stateful set represents a set of pods with consistent identities. Identities are defined as network and storage. And so the stateful sets will represent like a node in our case, the Cassandra cluster. And when we do the definition here, we have the CRD with customization to make it more modular. So you have like the spec, and then you have the kind, so you have your data centers and all of that. And this is a CRD for Cassandra. And these are the examples used in Cassandra. And this is how the operator works. You have the CRD that it checks into, and that handles like the stateful sets and the services and the secrets and all of that. And this is what I was talking about before. It has a set of states, and it reconciles those states and makes it so that it manages the state of the cluster. So if you have an update to your resource definitions, then the operator will look at that and say, okay, well, I can't just change everything all at one time. That would be insane. I'm going to take that and do it in a Cassandra specific way, which is to say, okay, well, if I have a change for all of my servers, I'm going to do it one node at a time. I'm going to do an upgrade one node at a time, and then reattach the stateful sets. I'll have the old image and the new image, and then I'll make sure that the configuration is fine on the new image, and then I'll detach from the stateful set, and then I'll reattach to the stateful set and manage all of that for you. And that's what the operator is doing behind the scenes, is to say, you have the operator here with they have the secrets and the services and all of that, and the CRDs. And then you have all of the services over here. And so there's a seed service, for instance, which handles, if you're familiar with Cassandra, when you start a new server within Cassandra, you have to have something that it can look to say, okay, well, how am I going to get awareness of the rest of the cluster if I'm just a starting node within the cluster? And seeds are just nodes that it designates like 2 or 3 per data center as kind of the starting points. And it really is lightweight. It has some minor persistent rationale. So there's a couple of reasons for it to exist on an ongoing basis, but for the most part, the seeds only really exist for new members of the cluster to join the cluster. It's just somebody to talk to. It's like a friend or a mentor to get into the cluster. Here, let me have you join this cluster. And so once it contacts one of the seeds, the seed will tell it, okay, well, let me just let you know that this is how we operate. This is all the ranges, and these are all the nodes, and these are all the data centers, and this is the metadata for the cluster. And they use a protocol called Gossip to communicate out like the real-time updates to members of the cluster after that. And so this is just giving you a view of what a data center looks like with the pods that represent the different servers. So when it comes to how do you deploy this, this is Cassandra simplified in Kubernetes. So instead of having to do all of this for you, having to do all of this manually, this is what the best practices are within Kubernetes. So, let me back up. This is what you would normally have to do yourself within a Kubernetes environment. And this is what the Cass operator within Cassandra does for you. And and like any operator that has a specific domain that it covers, it manages and does the best practices for you. It does the proper token ring initialization, 1 node bootstrapping at a time. It does the seed node management, 1 per rack, 3 per data center, whichever is more. And then when you're going to multiple data centers, what it does is it essentially says each control plane can exist independently. And so you can have a control plane in AWS, EKS, and you can have a control plane in GKE, in Google's Kubernetes engine, and each of them can have their own seed list. And then there's something in the CRD that you can specify called additional seeds. And so that way you don't need to do something like the Kubernetes Federation project. You can just say they can operate independently. And the only state that it needs to share is the seed list from the other data center. Because that's really the only thing, apart from networking being worked out between them, and that's something that's within the capabilities of Kubernetes today, or the associated tooling. But the additional seeds is really the additional information that you need across data centers. And so that's how you configure that. But within a data center, it's handling seed node management. And then all of the server configuration is within the Cassandra data center CRD. So all the tuning and all that kind of thing. It does, like I said, the rolling reboots of nodes when something has changed or when you're kind of upgrading the version in a new container. And it stores data in a rack safe way. So it does one replica per cloud availability zone or per rack. And it sets up racks evenly with new nodes. So it all does that for you, and it replaces dead or unrecoverable nodes. The multi-DC clusters are limited to one namespace currently, and it allows you to do scaling up and scaling down very easily. And so it really tries to bake in as, you're still in charge. I mean, like anything with Kubernetes, it'll do some things in an automated fashion, but you need to, you're the one that's the human behind the scenes, that, it's not self-aware or anything like that. It's a tool that automates most everything for you, but you're the one that does the declarative definitions. So this is an example deployment working across multiple Kubernetes workers. So you have rack 1, and you have a stateful set here with node 1 and node 4, node 2 and node 5, and node 3 and node 6. And then this is failure zone A, B, and C. And so this might be within a region, you have different availability zones. And then this namespace is what we talked about before. There's a single namespace, and Cass operator works within that namespace. And then external to our racks, you have the seeds and the definitions of the services. So that's configuring Cassandra and getting it all set up and operating it. But monitoring Cassandra is part of a sidecar. So there's a management API service, and it's a RESTful API. So there's a management API for Apache Cassandra, and then a metrics collector for Apache Cassandra. And so this sidecar operates within the same pod as Cassandra because it needs to basically gather all the details. And then also you can do things like, normally with Cassandra, there's a kind of a JVM task to be able to do certain things with it. But this exposes a management API in a RESTful way so that the operator can do various database operations, like if you're trying to do a stop and start operation or a reload the seeds operation, because sometimes the IP addresses change. And so the seeds may need to be reloaded within the cluster, for instance. And that's part of the under the covers thing that the operator does. But this management API makes it possible. And so we've already built that out within the project. And this is what it looks like. This is the metrics collector for Apache Cassandra. We've tried to put in there the most useful metrics. So at the back end, it uses collectd for the actual metrics. And then it also has a management API for the proactive, like the more like if you want to start and stop the instance and things like that, exposing that. But this is kind of the from collectd on a local level to Prometheus and then to Grafana dashboards. And these are the dashboards that are, throughput, latency over a period of time and all of that. So to be able to monitor in a proactive way. So, and this is how this operates, and is you have Cass operator that's talking to Cassandra to do what it needs to do for like changing CRDs or whatever other operations that you want to do. And then you have the metrics collector for Apache Cassandra that talks to Cassandra through the collectd that it writes to, and then it gathers that information, and then it puts that into Prometheus, and then that goes into Grafana as the dashboard with all of the different defaults, and then you can kind of extend it from there and customize it from there. So working with data, let's see. So this is kind of a way to show how you access the data. So you have a CQL endpoint, which you would normally have to access Cassandra, and you can access Cassandra through this, and you can look in the docs and how that's all set up and everything. And then The other ways that you access the data are through the Reaper UI, and the Reaper UI allows you to schedule repairs across your cluster. And again, repairs are essentially making sure the data is in sync as a background process. And so it's just basically showing the status and the progress of how it's going through the ring, and just keeping it all up in sync and in order. And then accessing the data when it comes to Medusa is doing the backup and restore to some sort of object storage. So there's the front end, the front door getting to your data, and then there's the synchronizing of your data, and then there's the backup and restore of the data. Scaling up and scaling down. So there's a simple command in order to do this, and you can do it through config files, obviously, through your YAMLs. You can change the size of the cluster and that sort of thing to from 3 to 4 or 4 to 10 or whatever else. And then, or you can do it through a Helm upgrade to say that the K8ssandra.size is now 3, for instance. There's more information here, but that's kind of just the basics of how you would do that. And this is something I talked about before, is start with why. I like that. Do you like learning query languages? Do you care about how your data is stored? Do you like installing running databases locally? So do you allow developers to execute direct queries against your database, or opening port ranges for your apps? And then from a perspective of a CIO, do you want to have dedicated projects and hiring people just to create APIs? And that's where Stargate comes in. Stargate allows you to say, well, on the back end, we'll serialize back to any Cassandra that you want to. These are the kind of the open source current versions. 3.11 and 4.0 was just released a couple weeks ago, running in production in various places already. And then the DataStax also creates an enterprise version of Apache Cassandra with some security enhancements and extra features. But those can be on the back end. And then Stargate, so instead of having a dedicated team, like it says, to create API endpoints for the back end of your data, you can let Stargate do that for you. And then it gives you the ability to speak CQL natively with it. So if you want to use the drivers, you can, and you can expose that to your developers, or you can just have them top one of these APIs. So you have REST, a GraphQL API, if you prefer, and then we're adding gRPC as well. That should be in the next couple of months. And then the one interesting one is the document API. So traditionally with Cassandra, you have a very rigid schema, and what you saw before was like the cities in these cities in the different countries and their associated populations. But say you have like some sort of like IoT scenario where you have JSON metric data, or you have like a JSON document with nested information in it. And you don't want to have to, like, maybe it's like a small side project that you don't want to have to create a rigid schema for. And maybe there's nested information that's there for some things, but not others. That's what the document API is for, is to say, it doesn't make you create a schema for this one. That's different than these two. So normally with Stargate, you could access your data with CQL, or if I've written the data with REST, I can access it with GraphQL. And if I've written it with GraphQL, I can reference it with REST or CQL. The document API is special. What it does is it says, you don't need to create a table. I'll create it for you. And then I'll take all of this nested JSON data. I'll put it into the database in a kind of a generalized fashion. They call it shredding. The details are in the project for how it does that. Stargate is an open source project as well. And then it will allow you to, it indexes all of that data as well. So you can query using just a normal document interface to say, this subfield is greater than this. And it will go and get that data based on the indexes that it creates when it creates that table. So that's pretty unique and helpful. We're also integrating Kafka and Pulsar as streaming options into Stargate as well. And so this is trying to be part of a more comprehensive ecosystem, because we recognize that data coming into Cassandra will not only have to be, I mean, there's definitely Kafka and Pulsar connectors for Cassandra, and that can be a sync into Cassandra here. But using Cassandra as a source, there's projects that are out there that are doing that right now, starting to do that, and we're integrating that with Stargate as well. So that's kind of where we're going with that, is to say that not only for kind of like the read write and normal circumstances, but also the read write from a streaming perspective, trying to better integrate that into Cassandra, into this whole ecosystem of K8ssandra. And so instead of querying the database directly, you have this layer right here that acts as a gateway, and it's also an authentication endpoint and the CQL endpoint, and you can use Swagger and Playground and that sort of thing to directly interact with your data in Cassandra. So it just gives you more options, and it helps your developers to get using Cassandra faster. And the nice thing is that K8ssandra, since you have all these components that you're going to need anyway, K8ssandra is nice because it packages all this up into one, so you don't have to worry about it as much. You can pick and choose, but you can also deploy it as a whole, and it manages it for you. So we talked about this previously, but under normal circumstances, the hinted handoff is for when you have a database that's down temporarily. That time frame is about 3 hours. It says, okay, if it's been over 3 hours, I'm not going to continue storing hints for this other guy. And so if the hint times out, or if it goes beyond that 3 hours, you need to be able to keep the data in sync, because there's a lot of different failure things that can happen. And so if you've seen the movie WALL-E, and I'd like to, the character named Mo in that movie, where he goes around and cleans up all the ship to make sure that there's no foreign contaminants, is what he calls it. I like to think of this whole, repair service called Reaper. It goes in the background and just makes sure everything is perfect, It's nice to have something like that, a proactive tool that goes and makes sure all of the data in your cluster is all in sync. And so this is also called Anti-Entropy Repair, which it just takes small subranges of data, and basically does a nested hash, so that you can say it's like a tree structure called a Merkle tree, and it goes through and it takes that hash and down, I think, 14 levels, and says there's a difference between the purple node and the blue node. And the nice thing about a Merkle tree is that it tells you specifically what branch they diverge. And so you can say, where that branch diverged in our Merkle tree, send across the data to make it consistent. And so it just does that little by little through the cluster. And that's what Reaper does to keep it in sync. And that's what this diagram is for the repair, you have a UI that gives you the status and the updates on how this is proceeding through your cluster. Because it basically does it in a very, it goes, if it's like 0 to 100%, it kind of just goes 0 to 100% little by little, and then it starts off at 0 again, because it just continually makes sure that everything is in sync. And this is the interface. You have your cluster, your schedules, and then it just goes through your data and keeps that in sync, but then also it gives you all of the different past ones. And so you can say, okay, for these tables and these key spaces, these have been run, and this has been paused, and these have been activated and started. So that's just the details here. But the K8ssandra is just Reaper is an open source project that came out of Spotify originally, and was inspired by the Op Center, DataStax Op Center repair service. Anyway, so it's an open source project that it starts it for you within K8ssandra. And then backup and restore is the last thing. That will allow you to do snapshot repairs in the case of when you might have a code change that goes through and pollutes your data. And so you want to back out of that, or is accidental deletion and all of that kind of thing. You want to be able to have a consistent backup that you can do. And so these are all this gives you an idea of what the whole ecosystem looks like. All components in a single distribution, and the components are pre-configured to work with each other. So it reduces the manual configuration. So what you're really doing is saying, okay, if I need a custom this or that, like my authentication widget needs to use our ADFS or Active Directory services or other things, or if I need to store certain things and secrets or other things, you can rely on the reasonable defaults for most of it, and then diverge from the defaults only when necessary. And then we've also done a lot of testing to make sure that it works with things like GKE, EKS, AKS, and things like OpenShift, because we know that, for instance, OpenShift is it's a kind of a different beast out there, because they do have specific concerns with security, and then they grew out of other things, and so they have different opinions about life. And so we've tested it with OpenShift as well. You can get the CAS operator specifically in the OpenShift operator catalog, but I think K8ssandra has been tested to work with it as well. This is backup and restores. I think that they're fully production now, but essentially you can use Helm to set the name of a backup, and then I think that at this point, this has all been settled. So I think that you just need to look at the project documentation, but I believe all of this has been settled. It follows the whole, beta, long time beta within Kubernetes before it goes GA, but I think it's GA right now, but you just need to check the project. And so to kind of bring this to a close, we have some additional resources out there for you. So K8ssandra.io is the whole stack. Stargate.io is the APIs that I talked about. NoSQL Bench is a benchmarking and load and data generation tool that can be used with K8ssandra to be able to make sure that you can benchmark your systems. And it also works with MongoDB and CockroachDB and Kafka and Pulsar as well. So it's a nice benchmarking tool for those things. If you're wanting to do things like Pulsar and Kafka integration, there's some tools out there for that. And then DSBulk is a way to unload from your existing database and from your existing Cassandra cluster, and then reinsert into a different cluster, or bulk unloading, bulk loading, and then counting for validation. And then, of course, there's a Spark Cassandra connector. So if you have a Cassandra cluster and you want to do data science operations on it, the nice thing is that Cassandra is very well suited to Spark, because essentially, Hadoop and Spark have a design philosophy that says, instead of taking all of the data and moving it someplace and operating on it in a single place, you want to move the computation to the data as much as possible. And so when you're selecting out, you break that up into the ranges. And it just so happens that Cassandra has ranges of data on each individual node. And so the Spark Cassandra connector is able to inspect that information, because it uses the driver, and the driver has visibility into where all of the different data ranges are. So the Spark Cassandra connector is very well optimized for using any Spark, so Dataproc and EMR included, Google and AWS, and I think HD Insights and Azure, and operating on data in the cluster. You just want to be a little bit careful, because if you have a real-time database, you probably want to have additional capacity. And sometimes we recommend that you have an alternate data center. So you replicate one data center for real-time operations and another data center for when you want to use the Spark Cassandra connector, when you want to do like daily dashboards and things like that. But this allows you to integrate also with things like Tableau and other things that use Spark under the covers. So I wanted to mention that for the people that are on the data science side of the audience. And that's about it. I appreciate everybody's time today in participating in the conference. And I hope you've gotten something out of this and can go out to K8ssandra.io and discover how you can deploy Cassandra in a more automated fashion and cloud native way. Thanks, everyone.